When you launch a new application, your entire architecture usually lives on one machine. It processes the logic, holds the data, and serves the user from a single isolated point. Send 100 users there, and the machine hums along perfectly. But send 100,000 users at once, and the reality of hardware limits sets in. The processor overheats, the memory fills up, and the entire application crashes under the weight of the traffic. Surviving the modern internet requires abandoning the single machine entirely. You have to build an ecosystem of duplicated, shielded engineering patterns to handle the load. This diagram illustrates load balancing. A balancer acts as a traffic cop, dividing incoming requests across identical servers. It might rotate evenly through the servers in a round-robin format, or actively track connections, shifting traffic weight toward the least busy machine. If a server suddenly dies, the balancer recognizes the failure and automatically routes requests to the healthy machines. Adding this distribution layer is the mandatory first step to turn a single application into a scalable production service. Once the traffic is distributed, those machines have to pull data. If your database lacks an index, finding a specific user is like reading a thick book page by page just to find one name. The system is forced to scan every single row. You fix this by applying an index to targeted fields, like a user ID. This gives the database a precise map, allowing it to locate matching records instantly. But it costs you on the other end. Every time new data is written, the database has to pause and update the index, slowing down data entry. You accept those slower write speeds on frequently searched fields because it is the necessary cost for dropping your read times from seconds down to milliseconds.